So now we're going to look at problems that have an expression in the denominator. So we have to rationalize using a conjugate. So we want to keep in mind our difference of squares, a squared minus b squared. That will be a plus b, a minus b. That will help us eliminate any expressions with radicals in our denominator. So a conjugate. If we have 4 plus root 3, the conjugate of that will be our 4 minus root 3. And if I were to do that out, I would get 16 minus 3, or 13. The next one here, we do have a negative for our first term. That does not change anything. We will have, sorry, I keep scrolling to the wrong page here. We will have negative root 3 plus root 6. Again, we have the sum and the difference of our a and b. So the first example, 3 over 2 plus root 7. So I'm going to multiply by the conjugate, which will be, try to make this out, 2 minus root 7. I'm going to go ahead and just figure out my denominator first. So it'll be 2 squared, I'll do this one totally out, minus root 7 squared. So that gives us 4 minus 7, which is negative 3. When I go back and look at my numerator, I'm going to put parentheses around that. I have a 3 times 2 minus root 7. And my denominator is a negative 3. Before I go ahead and distribute that positive 3 in the numerator, I'm going to notice, hey, 3 divided by a negative 3 here gives me a negative 1. So now I just have to distribute that negative 1, so I get negative 2 plus root 7. Number 2, I have root 5 minus root 2, so the conjugate here would be root 5 plus root 2. Lovely parentheses I'm making. Those addition signs a little bit better. All right, so denominator again, I'll just use a d for that, would be root 5 minus, or root 5 squared, sorry, minus root 2 squared. So we get 5 minus 2, which is 3. I do need to go ahead and distribute my numerator, or FOIL, however you want to put it. So I'm going to get 4 root 5 plus 4 root 2 plus root 10 plus root 2 times root 2, which is root 4, or 2. We do not have any like terms here. We'll talk about adding, subtracting radicals again in a moment. So that's our numerator, and it's all over 3. So for 3, our conjugate will be 3 root 3 plus 3 So I'll take care of the denominator first. The denominator will be 3 root 3 squared. And that's where some people have a little bit of a mistake. They forget to square both the 3 and the root 3. So I need to square 3, which is 9, and then root 3 will be 3. So I'm going to get 27, and then minus 9. So that's 18 for our denominator. Moving on to our numerator, I'm going to just change up the color a little bit. We're going to go ahead and FOIL that. So I get 6 root 3. I guess the color did not change. Surprise. Squared. And then plus 6 root 3. And then minus 9 root 3. And then minus 9. All right. These are like terms, so I'll have a negative 3 root 3. This will become 3 times 6, or 18. And 18 minus 9 is 9. Now, if I notice my numerator, it has both a 9 and a 3 in it. I'm going to factor out the GCF of 3. And the denominator is 18. Now let's try this one more time. I'm going to change the color here. I think it worked that time. So 3 divided by 18 would be 1/6. So our final answer is 3 minus root 3 over 6. And we can't do any simplifying. We have a 3 in a radical. We have a 3 as a term, and then 6 in the denominator. So this is as good as it gets right here. And then moving on to that last problem, the conjugate will be 4 root 7 minus root 3. And I'll just put ditto marks here, save some time there. So the denominator will be 4 root 7 squared. And again, put parentheses around that so you're sure to square both the 4 and the root 7, and then minus root 3 squared. So we have to do 4 squared, which is 16, and then times 7, leaving us with 112, and then minus 3. So we get 109 for our denominator. And now we'll multiply the 2 by that 4 root 7 minus root 3. And notice you can't simplify the 2 and 109, so we're just going to have 8 root 7 minus 2 root 3 all over 109. Now we're on to adding and subtracting. So you have to have the same radicand. You also need the same index. So same index of square root here, and we have 7. So 3 minus 5 is a negative 2 root 7. This next one here, we have the third root. It's 2x squared for both of them. Again, you have your imaginary 1 here. So it's 7 third root of 2x squared. We cannot simplify that 2x squared, so it stays in the radicand. Number 3, we do have to simplify a little bit. We have square roots and we have an 8, so we'll break the 8 up. 8 is 2 root 2. So I have 6 root 2. All right, and then I just have that minus 5 root 2 here. And then it's plus root 32, and 32 can be broken up to root 16 times 2. So it's going to be plus 4 root 2. And then I get 6 minus 5 plus 4, 5 root 2. I have root 12x minus 4 root 27x. So again, we'll break that up. 12 would be my 4 times 3. And then minus 4, and then root 27 is going to be 9 times 3x. So I get 2 root 3x. Minus 12, because square root of 9 is 3, root 3x. So I get a negative 10 root 3x. Next one, we have 4 root 8. So again, root 8 is 2 root 2. And then we have 3 root 50. 50 is going to be 5 root 2, because that's 25 times 2. So I get 8 root 2 plus 15 root 2, which is 23 root 2. And the last one there, we have 5 root 12. So that's going to be 5. We have a 4 and a 3. Plus 2 root 27. That's going to be 9 and 3. And then minus 128, which is 64 times 2. Hopefully you notice that all 3 terms will not have the same radicand, so we can only combine 2 of them. So the first one, we get 10 root 3. And then the next one, we get 6 root 3. And then it's minus 8 root 2. Combine the first two terms, so 16 root 3 minus 8 root 2. So again, adding and subtracting, same index, same radicand. Hopefully you did well on this, and see you soon.